All right, so we're going to go and kind of revisit the unit circle. We're not going to think of them in terms of radians right now. We're going to think of them in degrees. So we're not talking about pi, 2 pi, pi over 2. But what I've done on this picture that you all have in front of you is measure how big each of these angles are to this point. So for instance, for angle F right here, from here to F is 20 degrees. All I've done is just take a protractor and measure them. What I need you to do is to estimate the coordinate of each of these points. Now notice that 1 is right here. How big or how long is each of these blue tick marks? A tenth. Okay, so it's a tenth of a point. So looking at F, what would we label the coordinate for that one? 0.92. And then what's the y value there? 0.35. So what I need you to do is to fill in all of those numbers, and then I would like 6 people to come up and write their answers up there. So pick one of the letters and then come up and write the 2 numbers for the coordinate of your estimation. Get up and get your blood flowing on this beautiful Friday morning. And 6 volunteers. One more brave soul. Okay, two of them I'm going to change slightly. I'm going to change this -1 right here, the slightest amount, to be -0.99. Why am I doing that? No. Well, this is right here would be exactly where it's 1, and it's in a little bit from there, so it's not exactly 1. And this one, I think you just counted wrong a little bit. What should that one be? Any others that I'm not seeing a small mistake on? Are we good with these numbers? They're approximate, so they're probably pretty close to what you had. Now, what I want you to do in the space down below that picture is to try to come up with a connection with why we're doing this when we're talking about graphing sine and cosine. So it's going to require you taking out your calculators and kind of playing with some buttons and trying to see what is the connection between what we just did and sine and cosine. Yes?
So don't the sine and cosine they use like the x over the r, the y over the r?
Yes, but use your calculator and there's a direct connection. In very simple terms without needing to know any fancy ratios, nothing at all.
If you put in the angle, then it gives you for cos, it gives you that.
So if you put sine 238, what do we get? -0.84. Okay. And what do we get when we do cosine? So pretty much exactly what we have right here and right here. So remember that cosine goes with x and sine goes with y. We learned that in a previous section. So looking at all of these angles, if we were to graph all of these points, which we're about to do in a second, we're going to have a pattern that repeats over and over again. Here's the reason why. If we keep finding all of these angles, we're just going to continue around in a circle over and over again, right? So these values will repeat and repeat and repeat, which is what we talked about yesterday with those periodic functions that keep happening like a wave. So what we're going to do is to plot one rotation, because all of these green angles are within 360 degrees. We just know that once we get what it looks like, it's going to keep repeating over and over again. So on the next page, if you turn the page, we found this already. You have two graphs. Okay, I have them blown up, so I have one here and I have one here. You have them both on one page. What I want you to do is to graph your coordinates. So looking at this is how we're looking at it. These are just the x values. So you're going to have to either flip back and forth or recopy your x values by your x graph and copy your y values by your y graph. But you want to link them to the angle. So for instance, I am going to pull this onto here so I don't have to go back and forth. Okay. So looking at this, we want just the x values. So when it's 238 degrees, so we find that on here, 238, all of these, how much are each of these tick marks? 30, so this would be 60. So if you want to fill these in, if that would help you, that would be fine. So 238 would be a little bit before this one. We have to go just to the x value to negative 0.53. Now notice over here that up here is 1 and down here is negative 1. So each of these are 0.2. So if we want to go to negative 0.53, we've got negative 0.2, negative 0.4, negative 0.6. So you want to put your dot and do the best job you can, but you want to plot all of these points. So I'm going to give you some time to do that, and I'm going to also be doing that up here and trying to make it look as good as possible on this big screen I've got here. Now this is the only time we're going to be plotting these. This is just to get what the curve looks like, and then we'll always know that it looks this way. So this is the only time we're doing this. You're going to be an expert on this. Now, if you were to connect your points, what would be a good way to verbally describe what the curve would look like? So if you were kind of like a V, yes. Okay, we're going to make it a little bit more curved, so it's going to look more like a bowl or a valley. But it is going to start up at 1. So it's going to look something like this. So remember, what you just graphed is the cosine values. So this is what a cosine curve looks like, and it's going to repeat over and over and over again. This is one cycle of cosine. So it starts at the top of the hill, goes down into the valley, and comes back up the hill. And you're going to just repeat that over and over again, so it'll look like a wave. So cosine starts at the top, goes to the bottom, goes to the top. Always. Okay, we're going to do the same thing with our y values. Oops. So now we're graphing all of the y's. I will be graphing at the same time you are. How would you describe this one if we were to connect all of them? I think we can agree on the beginning part of the shape. It's going to look something like this. Okay, the end of it is hard because we only have 2 more points to connect, but knowing that it's going to be symmetrical, we know we have to go through those points down there. Oops. Cleaned it up too much. It's going to look something like that. And this is going to repeat over and over again. So again, it will also look like a wave. So this is your sine curve. 1 cycle of sine. So look at the differences between the two, but know that they're both going to repeat. So somewhere along the side of each one, I want you to draw kind of a mini one. And sine is going to start here and do this. And put a little dot at the end because that's 1 cycle. And then it's going to repeat. And it's going to repeat. And it's going to go on like that forever and ever. Up above, do the same thing for the cosine. It's going to start here. And the end of the cycle's there. End of the cycle's there. So notice that they pretty much look the same, right? It's just a wave going on forever. It's just where it starts and ends is different. Right here? The reason we don't start going up right here is because we want it to kind of be a mirror image of what's up here. And if we would plot all of the points, like if we would find more angles, you would see that it would fill in coordinates like this to be more of a symmetrical curve. Other questions? Today is the day for questions because we're just doing notes. So I want you to fully understand this. You ready to move on and start looking at what the equation looks like? All right. So what is the main focus for our difference between the two graphs? Because we looked at how they were the same. And you don't have to redraw these right here, but I'll just remind you that cosine looks like this. And sine looks like this. So what's the main difference? The starting point, exactly. So cosine, let's write this right here. Cosine starts where? And in parentheses, I do want you to put or bottom. We'll learn that in a second. And sine starts, I'm going to call it middle, because it's not always going to be 0, but it does start in the middle, because we're going to be moving sine and cosine up and down, so it's not always going to be right at 0. Okay, so cosine is going to start top or bottom with a valley or a mountain peak. Sine always starts in the middle. That is the main thing that you need to remember when graphing sine and cosine. Anytime you see this symbol right here, which is Greek letter theta, it's the same thing as x, so don't be alarmed. I know I've told you that before, but you're going to see it quite often. All right, so we have 2 equations that we're looking at today. Okay, the sine curve and the cosine curve. So write down these 2 equations. We're going to write down what these things do to the graph. You have them written down. Why did I say write them down? Okay, so when we were graphing before, what does this number in front do? Remember? Anytime we're graphing something like a parabola and we had an a in front, V graphs, anything where we had a coefficient in the front. Yep.
Like this steepness, or like if it's positive or negative.
Yep.
Okay.
The steepness of it, so it makes it taller or shorter. Okay, it makes it more steep or less steep. And the positive and negative tell you if you flip it or not. So that's what we're going to be looking at here. This actually relates to the amplitude that we were talking about yesterday. So if it's a big number, it's going to be tall, and it's going to be more steep. If it's a smaller number, then that's only going to go to 1/2, for instance. It also tells you if it flips, if it's going to be negative. Same rule as before. Cosine, this just tells us that it starts top or bottom. And then B. B is the number of cycles that you're going to draw from 0 to 2 pi. And I'll explain what that means in a second. All right, so this is the same. We've got amplitude, and it may flip if it's negative. This one starts in the middle, and this is the number of cycles. From 0 to 2 pi, or 0 to 360. Okay, one rotation on that unit circle. All right, this is something important to note because you will see this. This is your B value, which we just learned up here is the number of cycles from 0 to 2 pi. So in this equation, if we have pi right there, how many cycles will we draw? What is this as a number? So you're going to draw a little bit more than 3 cycles. Because whatever that number is tells you how many times you're going to draw that curve. Regardless if it's pi or a 6 or a 2, whatever it is, tells you how many to draw. Questions yet? All right, so let's jump into this information right here. Period equals 2 pi over b. That will stay on the board as a formula that you're able to use. Okay, or b equals 2 pi over the period. And remember that b is the number of cycles from 0 to 2 pi. All right, so let's try writing an equation for this based on what we just learned. So let's look at this. Is this sine or cosine? Cosine. Okay, how did you know that? Starts at the top. So we know it's cosine. What number should go in front? 14, because it's the amplitude. Remember, amplitude is the distance from the midline to the top. So it's 14 cosine. We just need to write how many cycles there would be from 0 to 2 pi. Now the picture only shows from 0 to pi. So you have to imagine that it goes all the way out to 2 pi. How many full cosine cycles would you have? Right now we have 1, 2, and then we would have 3, 4. So there's your equation of that curve. Pretty straightforward, correct? All right. Let's try this one. It is cosine. What's the amplitude? And how many cycles from 0 to 2 pi? Half of a cycle, right? Because the full cycle is right here, and right at the point where it's 2 pi, that's only half of the cosine cycle. So we've got 1/2. They may also write it like this, and I want you to write both versions. Now, sometimes they'll use x I'm going to use theta just to show you that you can use both. They may write it like this. That's the exact same thing. And you'll need to know that because you'll see that on the worksheet. Questions yet? So that's just kind of a crash course on making formulas from the picture. Let's actually go through and look at some similarities, figure out what's going on, get some more practice with this. Remember that A is the amplitude, B is the number of cycles from 0 to 2 pi. So let's look at these. All of these have one cycle from 0 to 2 pi, correct? Can we agree on that? All right. So this one, what's the amplitude on all of them? 1. Okay, so we don't need to write a number up here. Is this sine or cosine? Do we need to write a number here? Okay, I'm going to start using theta just so you get used to seeing it. So amplitude is 1, number of cycles from 0 to 2 pi is 1, so we don't need any other numbers in there. That is y equals sine theta. What about the next one? What's the whole equation going to be? Y equals negative sine theta. Remember that negative signs flip it upside down. So if you had a mirror right on this x-axis and you flipped it upside down, it would look like that. So sine, when it's negative, instead of going positive first when it's positive, when you have a negative sign, it goes negative first. What about down here? They're both cosine, correct? That's just our standard cosine curve. The next one, yep, this is the negative, what negative cosine looks like. So the way that I describe the difference between positive and negative with sine is the direction you travel first. That's not how you think of cosine, because positive cosine actually goes down first. But cosine you can think of as where it starts. It's starting positive when it's positive. It starts negative when it's negative. So you have to kind of think of those negative signs differently with sine and cosine. Yep.
You had it like instead of going like not up and down, but so it's going to the right is positive. If you had it going to the left, the whole thing like going left, so it's be going negative, would the theta be negative then? Yeah, like that.
The graph actually does continue to the left. We're just not drawing it. So putting the negative sign on the theta won't change anything because that reflects it over the y-axis, and it's a mirror image left to right. So that won't change anything. Other questions? So I've got a little bit more variety on the next ones, kind of like the two we just did before this page. Again, I want to write this. Just to get used to thinking about that. We've got these 4 pictures. I will be throwing in some very basic ones, so don't get alarmed if you see something like this. What's the equation of this one? Sine 2 theta, or 2x. Everyone see why? There's one cycle from 0 to pi, so if you would extend the graph out to 2 pi, there would be another full cycle there. So 2 total cycles. So you kind of have to use your imagination and thinking, okay, if I kept this going till 2 pi, how many would there be? This one. We know the amplitude is 4. Is it positive 4 or negative 4? Positive. What is it? It's cosine curve. How many cycles are there? From 0 to 2 pi. 4 cycles. Next one. y equals 3. Yep, I'm going to write it like this so that you get used to seeing it, because that's typically how the worksheets will do that. You could also write 1/2 theta. I'm not going to count it wrong on the test. The next one, there's a lot of curves, so I'm going to give you a tip on counting. All right, so let's start it out though. This is a y equals what? 1/2 for the amplitude, sine or cosine? Sine starts in the middle. Now, it's good to make those dots and count. We're only going to count to pi because we know we can just double that. So we're going to travel along until we get to the end of the cycle. Remember, sine goes up, all the way down, and back up. Up, all the way down, and back up. Up, all the way down, and back up. So you're able to just count how many dots you have. There's 3 cycles there, so altogether there's 6. Questions? Yes?
How can sine have an amplitude when it starts in the middle?
Remember, amplitude is just how the distance from your midline up or from your midline down. It's just how far away it is from that center line. Other questions? Let's try graphing from an equation. So we're going to graph from 0 to 2 pi. And we're looking at these 4 equations. So let's break this down here, talk this out. We have y equals -3 sine 3x. So tell me what all of this stuff means. What does the 3 mean? Not the negative, just the 3.
That amplitude is 3.
Okay, we've got an amplitude of 3. So let's put that on our graph. That means these 2 orange lines become 3 and -3. Okay. The 3 right here means what? 3 cycles. All right. And sine means what? And the negative. Okay, so we travel down, or you could just write that it's flipped upside down. So we're going to start in the middle. We're going to travel down first, and we're going to create 3 of these sine cycles. And the more practice you get, the more, I guess, beautiful your sine curves will look. But try to make them look curved, not pointy. Try to make them go all the way up to the top of the amplitude and all the way down to the bottom to fill that whole graph. So there's 2, and it's good to put the dots on the end so that you know how many you've done so far. And what do we label at the end? 2 pi, because that's how we're graphing them, from 0 to 2 pi. Okay. Next one, what should we label the orange marks? 1/2 and -1/2. Cosine is going to start where when it's positive? Okay, so let's put a dot there so we know what we're doing. And how many cycles will we draw? A little bit more than 3, 3.14. So we've got 1, 2, 3, and a little bit more. We always label 2 pi at the end. I'm looking for that when I'm grading your test. So every piece in the equation gives you a hint at what it should look like. Next one. What are my orange marks on my graph? Where does it start? How many do I draw? How much, Ryan? And how'd you get that? 3 pi divided by 4 in your calculator to know how many you're going to draw. So looking at this, I'm going to draw 1, 2, and about a third more. And then we're just estimating. Label the end with 2 pi. All right, negative cosine x over 2. Tell me what I'm supposed to do. These? 1, negative 1. Start at the bottom. And how many do I draw? Just half of a cycle. So I just go to the top of the hill, label 2 pi. Now on all of these, we're going to label the period, which is the length of one cycle. And then we'll be done. And we have this formula that will tell us what it is. The period is always equal to 2 pi over whatever our b value is. So we don't actually have to sit here and count exactly how long the cycle is. So period is going to be 2 pi over our b value. Well, our b value was 3 on this one. So the period is 2 pi over 3. That's how long one cycle is. So that would be this value right here if you were going to label it on the graph. One cycle is 2 pi over 3. On this one, we've got pi. So 2 pi over pi would be what? So right here is 2, one cycle. Period on this one. I have to do some simplifying with fractions. How am I going to do that? Because really we're taking 2 pi divided by 3 pi over 4. How do we divide fractions? Not really cross multiply, because technically cross multiply is when you have an equal sign. But I know what you're saying. What should we do? We only need common denominators when we add and subtract. So really, what are you doing? When we divide by fractions, what's our process? We multiply by the reciprocal. We have to flip the second one. So this is 2 pi over 1 multiplied by 4 over 3 pi. When we multiply fractions, can't we just think of it as one big fraction? So what cancels out here? Pi's, and we're left with 8 over 3. So looking back here, that spot right there is 8/3. This one, 2 pi divided by what? This is just like what we were just doing. 2 pi divided by 1/2 would be? Now where do we put 4 pi on this graph? At the end of a full cycle. Well, we don't have a full cycle on here, so if we wanted to label 4 pi, it would be right there. Questions?